Hello, it's Ted Ritzer, host of the Greening Government webinar speaker series, which is a collaboration between my department, Alberta Environment and Parks, the Alberta Climate Change Office, and the Municipal Climate Change Action Centre here in Alberta, Canada. And the format of the speaker series is usually we have up to a maximum of 40 minutes for presenters to present, followed by up to a maximum of 20 minutes for a Q&A session. And today we are joined from London with Tracy Miranda of the Eclipse Foundation. And the topic within this series, the purpose of this series is to help governments in Alberta reduce their carbon footprints and to also help them grow their green economies. So it's really interesting when I've kind of looked at the use of different technologies to help in what I would call an internet scale response to climate change. I came across the Eclipse Foundation, and Tracy agreed to present into the series on how open source technology could be used at internet scale to help in our responses to climate change. So Tracy, it's so wonderful that you're able to join us from London. Thanks so much for agreeing to do this.
Yeah, no problem. Thanks so much for having me, Ted. It's really great to talk on this subject. So yeah, good morning to everybody, or good evening, if as is the case over here in a somewhat overcast UK. So what I'll be talking about, as Ted mentioned, is open source software and the sort of proven approach we have in open source to innovating at scale and harnessing the power of communities. And in particular, I'll be looking at the Eclipse community and its working group, because those provide great case studies to show what does this approach really mean and suggest why this might really work for tackling climate change. Okay, so let's get started. I'll start with an introduction. So first of all, I'm CEO and founder of a company, Kichwa Coders, and we provide consultancy to startups, enterprise companies, even government agencies who want to adopt and make the most of open source software. And that's in the embedded and scientific domain. So I am often mistaken, as it turns out, for someone who works for the Eclipse Foundation, just because I am so heavily involved in the community. So I sit on the board of directors, and I'm involved with the Architecture Council there. And also very recently, I've taken over as the chair of the Science Working Group. And I'll touch on some of these groups and the work we do as I go through this presentation. But I want to start with just this basic idea of what is open source software, particularly for anyone who may have just heard it in passing or isn't that familiar with it. So by definition, we talk about open source software as being software with the source code that has a specific license which enables anyone to inspect, modify, or enhance it. Now, what this means in practice is that, well, I like to give the example from when I was first starting out doing consultancy on open source. And I would be helping all these companies to adopt open source at a time when they didn't know that much about it. And so basically, they would want to use it because they had heard that it was free, and that meant that they wouldn't be having to pay very expensive license fees for proprietary software. So my job would be to go in and say, well, yes, it's free, but it's free as in a free puppy. So you still have to take care of it, look after it, well, train it, and as the case may be, clean up after it. So there is some effort involved with open source software. So it's just not completely magic. There's a work that goes into it. But out of open source software and those communities sort of spawned an open source approach. So built around this idea that you could have software where the source was completely visible and people could take it, modify it, and change it. And around that grew these transparent processes. So it became quite open as to how the software was being built, how decisions were being made, and how it was being architected. And alongside that came the idea of meritocracy, that people should be involved with the project for the contributions they make, not based on which company they were part of or any other sort of shortcut to being involved. And as a result, if you take those things and so you put together open source software, great technology, and an openness which allows people to see how it evolves and get involved, you end up with this creative collaboration where people come and start working together in a very, very creative way. And without needing that permission of having to pay for something or having to request something, this inspires a great freedom to innovate. And that's one of the reasons people who get involved with it love open source so much. And one of the reasons I stay involved with it constantly. Okay, so in the context of Eclipse, so Eclipse is probably really best known for its Java IDE, which was initially developed by IBM back in 2001. And they made that free and open source. And some of the things that helped there is it had a great plugin architecture and a very commercially acceptable license. So lots of companies were really intrigued to work with the Java IDE, but they had one big hesitation, and that was that they were still afraid that they weren't ever going to be on a level playing field with IBM. So back in 2004, the Eclipse Foundation was created to look after the Eclipse IDE and to provide a level playing field. So how the foundation works is that it's run as an independent not-for-profit corporation. And in this way, it provides this very unique model for open source development. So the key thing, and I'll come back to this later, is vendor neutral governance. But in addition to that, it provides services for things like IP management, a licensing model, IT infrastructure for building software projects and delivering them to the end adopters, and very importantly, the ecosystem development and support. So let me give you a real world example that I'm really familiar from my work. And this is a specific project which is called the Eclipse C and C++ development tools. It was originally developed by, a lot of work was done by QNX, who are now part of BlackBerry. But because it was open source under the Eclipse Foundation, it meant that every company could take it and start to use it and adapt it to their needs. And so every hardware company out there did. So I think it was the case that almost every hardware vendor, if not every hardware vendor, used the CDT. And where I was getting involved was with a lot of hardware startups who didn't have the capability to develop their own development environment. But by taking CDT, they instantly had some software which would allow them to compete with the big hardware vendors. And that allowed them the freedom to focus on innovating in their own hardware. So in this way, the C and C++ development tools really drove innovations in hardware, in different types of chip configuration, systems on the chips and things like that, as well as in software, some under the scope of companies and some in the open source. And we've got some great tooling there for things like multi-core debug. And the thing that really made the big difference was that the open source governance that was provided by the Eclipse Foundation, because what it meant was that you could have this level playing field. So no matter whether you were a big company or a small company or institute, the rules were set out and everybody could adhere to them. And so this is, I guess, what I call true open source. And for me, this is what it looks like. So this is a snapshot I took this month from the CDT project. And you can see that there's lots of member companies who are involved. They've got all the icons at the bottom. So you've got people like Google and Red Hat and Ericsson and QNX. But side by side with them, you've got people like my company, less than 50 developers and other companies. If you look at the pie chart, you'll see the contributions are coming from the big companies, the small companies, what's marked there as unaffiliated individuals who want to contribute as well. So this is the magic of the open source, where you have governance. That means everybody can operate and the rules work. And then this is where it works best, because then everybody does involve and you have a really healthy, thriving ecosystem. So from those early days with the IDE, one of the things we learned as being part of the Eclipse community was that open source with good governance provides an effective approach to innovating and creative collaboration. But the big question from there was, is this a one-off, or does this approach actually scale to other areas? So over the years, the Eclipse Foundation and the Eclipse community have evolved. And one of the more recent evolutions has been the formation of Eclipse working groups. So in particular, Eclipse has these 3 working groups, which are very focused on emerging technology areas that are very high growth. So there's the location tech one, which is focused on sort of mapping and location aware technologies. And the other 2, which I'll go into more detail, the science and IoT groups are particularly interesting and ones I've got direct involvement with. Okay, so the IoT group is related to the Internet of Things. And I believe in this day and age, I can't go to a tech conference without having some track or some technology talking about the Internet of Things. So I'm going to talk first personally. When I think of IoT, I often think of smart homes. But for me, I've never really wanted a smart home, but I have been quite keen on having a smart chicken home. So we've got a little garden. Don't think you can quite see it, but we keep chickens. And that's my daughter manhandling the chickens. So she likes to get stuck in, but not consistently. So often when we travel or when we're away from home, and we'll get the neighbors to look after the chickens. But we really could do with technology there that helps out, like just knowing, let's say, a sensor that detects when the chickens have gone into the house, so we know if all of them are in for the night, and we could have a door that automatically closes. Or in the winter, sometimes the water they have, it freezes, so it's really nice to have a temperature sensor that would tell us what the temperature of the water was, so we know if we have to do something about it, or go turn on the heat lamp or things like that. So that's the kind of thing that I would really love to have automated. And it's an area where maybe 10 or 15 years ago would be quite hard work to do, and the technology just wasn't there. But today, this area is moving really, really rapidly in the whole Internet of Things space. So I think, time allowing, I could very well have my very own smart chicken home, and maybe the chickens would be a bit less manhandled, or maybe not. Okay, so the Internet of Things, it sort of falls into these different tracks of, one is the whole smart home, which is very consumer facing, and that's probably the one you hear a lot of in the press, and things like smart fridges and smart this and smart that. But also becoming a very big thing is smart cities. And we have lots and lots of different things where you've got cities all connected up. I like the stories of hearing where Amsterdam have all their boats can be connected, so people know whether they're getting flooded or not, or in Moscow, where all the snowplows are all connected up with sensors, and you can operate them centrally or just know where they are from a very central location. So we're starting to see all this technology driving growth and development in cities. And then, of course, there's the industrial side of the IoT, and not just factories, but even things like agriculture are just starting to get kitted out with lots and lots of sensors to help manage things and make systems more efficient. So around this, we have the Eclipse Internet of Things Working Group. So the definition of the group is that Eclipse IoT is an open source community aimed at building and promoting open source software, open standards, and open collaboration models needed to create an open Internet of Things. So the idea is to get together all these companies who believe that the Internet of Things should be built on open source and get them working together on the software and on the standards. And as it turns out, there are quite a few companies that believe that the Internet of Things and this open approach will work. So this is a snapshot of the members of the Eclipse IoT Working Group. And I have no idea if it's up to date because there are constantly new members joining in. But you'll see, I think in the series, there have been talks from Sensor Up, and you might see a few others. So there's lots of different companies coming in to collaborate. And one I'll point out is Bosch. And the interesting thing about Bosch is that it's not a traditional software company that we would have had as part of the Eclipse Foundation, say 10 years ago. But this is actually a company who builds things, who have cars and washing machines. But they see, everything is going to be connected with sensors, so they want to get involved and they want to collaborate with other companies like Coders to work on scaling up solutions for the Internet of Things. So there's a whole host of projects being brought in by these members, and at various levels. So some are for services, some are for the back end, some are for the gateways, and some are for end devices. And it's quite a challenging thing to have all these different types of technologies coming in from different approaches. So specific companies are trying to solve specific problems in their arena, but they're trying to build tools and frameworks that will have broad applications. And so that's where the working group comes in, and it will have a steering committee and it will have the backing of the foundation. And so they're doing really interesting things there. And one of the key white papers they've published sort of looks at all this technology and then organizes it in a way that people can easily understand. So there's this paper, and I really advise you to have a look at the Eclipse IoT website and download the paper. It's the 3 IoT software stacks. So one stack is focused on constrained devices. The second one is on gateways and smart devices, the gateways which will be coordinating the devices, collecting all the data. And the third one is on the actual cloud platform, and that's the layer where you have the management of the data, and the device might be providing upgrades, and it might be tying into all your various applications which the end users are using. So all those 3 stacks, while they're focused on those areas, also have cross concerns, things like that major concern of security. And as they say, the S in IoT. And then there's things like ontologies, as well as just the tooling in SDK. How are you actually going to develop all these? So these are all sort of big scale problems that are being looked at by this working group. And so Mike Milinkovic, who's the executive director of the Eclipse Foundation, he's come out quite strongly with the statement that the Internet of Things will be implemented using open source software platforms. There is utterly no alternative to this outcome, and anyone who says otherwise is fooling themselves. And this is something we fundamentally all agree with in this working group. And the reason is that we have the example of the internet itself. So the internet itself is, just this most radically open platform, and the World Wide Web made it free for everyone. So once you had that, you then had open source technology, which was developed on top of that. So you had things like Linux, the Apache web server, and browsers like Netscape and Firefox. So every big technology giant you have out there today, the Googles and the Amazons of the world, they're actually building on top of that infrastructure. And it wouldn't be possible without that open nature of the internet itself. So the modern digital world is all based on open source, and it's all it enables us to get to this massive scale, which the internet has got to today. So taking that idea and applying that to the Internet of Things, you sort of see there's, and Mike wrote a blog post about this, which outlines why this will be the case. So number one is just scaling. So you have all these estimates about how many sensors will we have on everything, and every time I go to a conference, there's talk about sensors on things, and there's literally sensors for everything. There's sensors for tires, there's sensors for coffee machines. I've also seen talks where they talk about sensors for cracks, for say archaeological heritage sites and the like. So let's say you've got 50 to 70 billion sensors being provided in the next decade. Any solution that isn't open source is just simply going to be unaffordable. It's just economies of scale. You can't compete with a proprietary solution. Second reason, which we've touched on before, is this whole idea of freedom to innovate. You would need permission to go and take these different technologies and to integrate them to come up with new ways of working and new ways of combining things. There just aren't any barriers when it comes to open source to being able to do this. Okay, third reason is this idea of interoperability. So in the Internet of Things, there's a lot of talk of standards and how we should all center on standards. Now, one of the biggest drivers of adopting standards is having shared implementation. So when we have open source implementations, then this really drives adoption of a specific open source standards, and we're starting to see lots and lots of examples of that. And you've got things like MQTT, which are really being adopted very widely now, and that has open source implementations. And finally, the fourth and final reason given why it will be the case that the IoT will be built on open source comes down to developers. So developers are completely vital to scaling up the Internet of Things, and developers love open source, and developers need to be empowered. So open source empowers and attracts them, so it's just not going to happen without them. So it's not going to happen without open source. And one of the other things we kind of like to say is one of the reasons open source really works is no matter which company you are, there are always more smart people outside your company than inside. So taking advantage of open source is really kind of leveraging everybody out there. And I think that is really the only way that it can scale to this internet or Internet of Things level. Okay, so what I'll say is if you're interested in that, go check out the website here, have a look at all the projects, the member companies, and there's various ways to get involved depending on whether you're individual or as part of a company or just generally interested. And they've got things like open test beds, which provide again examples which people can use to really illustrate fully fledged solutions based on open source. Okay, let's see how we're doing for time. Okay, next case study. So I'm going to switch tracks now to talk about another working group. And in this case, it's the science working group. And this one is very close to my heart because I'm one of the founding members of the group, as well as I'm the current chair. So in this case, this working group has this focus on coming up with reusable open source software tools and services in the scientific domain. And once again, we're focused on solving some specific problems. So when it comes to scientific tools, those problems are centered around big data. So I'll take this example from one of our member companies, Diamond Light Source, which are the synchrotron in the UK, who are just doing amazing work in enabling sort of, it's like the world's biggest microscope, and they study everything there from chocolate to dinosaur bones, all at the microscopic level. So one of the scientists there, back in 2005, had made the statement. He said, "I have all the data I have ever collected on a floppy disk and process it by hand." So that very same scientist in 2014 had collected 1 terabyte of data in 2 months. And it's just getting, it's growing exponentially from there. So I hesitate to guess at what he's at in 2017, but just the sheer technology of the detectors they use and the amount of data they can capture and how quickly they can see is just growing at such an exponential rate. So big data is one of the challenges of scientific software, and alongside things like just scaling up the tools, reproducibility is a big one. So if you have all this data and if you have these experiments, how do you enable somebody else to reproduce that and to come to the same conclusions or see that your conclusions are correct? Also, similar to IoT, we talk about integration and making different tools that are developed at different places work together, and doing that with perhaps limited resources. And then also in the scientific domain, they're saying how do we get recognition for software and the big role that software is playing in advancing science and in advancing these experiments. So these are the common challenges that a group of different companies and institutions, well, I should say individuals in that group, started discussing and started saying, well, can we get together and do something about all these? And so the science working group was a very grassroots affair. So individuals got together representing their institutions and said, let's make this happen, let's collaborate on these. And again, I was involved as well through some of the work we're doing with Diamond Light Source. And one of the things I really love about this group is that we have such a diversity in our members. So we've got scientific institutions like Diamond Light Source and Oak Ridge National Labs, based in the US. Then we've got big enterprise companies. So take, for example, IBM, and we've got Airbus, who are in France, and we've got their flight physics department who are doing some really interesting stuff. So that falls in the scientific domain. And then we've got the small and medium companies like myself, and we've got a number of universities. And what this slide really doesn't show is also the individuals who are involved, because they make a big difference too. So when we talk about individuals, we have a small but growing group, and I think we like to keep it fun. This was the unofficial motto that I think somebody appropriated from the Martian film, but it kind of represents the groups in terms of, we want to solve these things, we want to take on these challenges, but we want to keep it fun, and where possible we'll try and meet face to face, and actually had some good meetings at a conference just last week. So really nice to sort of get some face time with other members of the group and really keep that kind of community spirit going. So when the group first started off, there's a lot of focus on scientific workbenches. So places like Diamond Light Source and Oak Ridge had these scientific workbenches in their specific domain. So whether it was high energy physics or nuclear physics, they had these big scientific workbenches. And by virtue of these meetings and these collaborations, we were able to see that actually there was a lot of common stuff in all these workbenches. And we were able to break these down into specific building blocks. So one was visualization, sort of 2D and 3D. One was workflows, of scientific workflows of how data might move through a system. Then common data structures was the third one. And the fourth one is Python scripting. So Python itself being a major part of the scientific community, that was a common theme through all the workbenches. So as a result of having these conversations and identifying these common areas, we're then able to start projects in each of these areas. So I won't go into details of the projects, but I will give you the website you can have a look at later. But I'll just touch on one, which is the data structures one. So under the guise of having common data structures, we have a project called Eclipse January, which stands for Java Numerical Arrays. And this gives a way of having numerical data structures such as n-dimensional arrays, which are common and can support powerful mathematics and ways of slicing and looking at them. So if anyone is familiar with Python, this is basically a NumPy for Java. But the idea was that if we all standardized on one project and one API, then all the different technologies we were working on would work together well. So this was one of the key projects of the group, and we've been working on it for a few years. So the first part of the code base was contributed by Diamond Light Source, but by virtue of them contributing that, they then had the community come together and provide code contributions, write documentations, and provide testing, and just improve things in general. And then what we found was that actually the project had applications much broader than science, and it got picked up by Intel to be used as part of their data analytics platform for the Internet of Things. So they were using the project as a canonical way to share data between Java and Python. And they were using some of the features where you could tag metadata on it very heavily. So I think for us, it was no big surprise that this technology, which had sort of come out of the scientific sector, would have these applications for the Internet of Things. Because it's something that we are aware of, that all these ecosystems, like the Internet of Things, like science, and like location tech, there is a lot in common. So if you take a look at this chart, it has some of the specific areas that we've touched on, particularly in the Internet of Things, with gateways and device management and messaging protocols. And then likewise, if you look at the science side, you've got analytics and 2D visualizations and 3D visualizations and high performance computing. But then you have these areas that overlap. So at the intersection of science and the Internet of Things, that's where you have machine learning, that's where you have analytic insights. When you take something like location tech and IoT, that's where you have geo-aware Internet of Things for things like indoor positioning, just knowing where you are or where your sensors might be. And at the heart of all of these things, there's a common thread of data, visualizations, analytics, and of course, just the idea of open source and open data. So we know there's a lot of overlap in this area, and we really benefit by being part of communities which are connected to other communities, so we can take advantage of that to benefit from each other. Okay, so just going back to Eclipse Science, or even Eclipse in general, we have a load of projects. I'd encourage you to have a look. We like to refer to them as the treasures of the science working group. And we're starting to diversify. I'm going to mention this project as well, because there's quite a few in our community really excited about it. That we just keep building and building and going into new areas. And one of the new projects is a quantum computing framework that's coming out of Oak Ridge National Labs. We like to joke that it finally means we can get a cat and put it in a box. And I think for now that's the extent of what I know of quantum computing. But yeah, looking forward to finding out more with this project. So yes, to check out that that project and all projects from Eclipse Science, please have a look at our website and check out the membership as well. And you can get involved again as an individual or as a representative of your company or organization. Okay. So I've kind of looked at the example of the Internet of Things working group and science working group. And just to sort of tie this up, when you talk about an open source approach, it comes down to these three things. You know, number one, just keep it open and transparent, open so people can take things and use things without having to sort of jump through hoops, and just have a transparent approach to it, so everybody is working on common ground. And then number two, really essential, good governance. Really vital to have that level playing field. Otherwise, you could never grow the communities and keep them going long term. And then the third one is community, just fostering the community, doing what it takes to grow it around the open source technology. So that's the open source approach. And when you take that model and put it into this formula for working group, what you're looking for is self-governing groups, which can be distributed. So we can work like the science working group. We've got people in the US, in Norway, in the UK, in France. And it all works because we're focused on these common goals. So whether it's big data in the case of Eclipse Science, or scaling the Internet of Things and coming up with solutions for smart cities or industry in the case of the Eclipse Internet of Things working group. So you have to foster that community, and you have to foster this technology, and go back to that open source approach again with your good governance, and keeping things open, principles of meritocracy as well. And then what you find is if you do that, then it just keeps kind of multiplying. And as at an EclipseCon just last week, and there was yet another specialized working group that was announced. In this case, it was the Open Mobility Working Group, which in their case are looking at advancing simulation environments for transport applications. And this is something being driven by DLR, which is the German Aerospace Center. So it's yet another group focused on a specific area that's going to follow these principles. So it can work, and it is completely reproducible over and over again. So I'm going to throw this out there as well. So just kind of thinking on this topic, well, so how could we take this approach and apply that for climate change? So what would a climate change working group look like? Who would be the members? What would they collaborate on? What data should they share, and what problems would they solve? So I don't have the answers, but I'd be happy to talk to anybody who is interested in trying to answer these questions or pursue just this line of thinking in terms of climate change using this open source approach. So yeah, the open source approach provides a proven way to innovate, harness the power of communities, and solve large-scale problems. And I firmly believe that this kind of open source approach could really provide the perfect framework for tackling large-scale problems like climate change and just doing that at scale. So thank you very much for listening, and yeah, I'm happy to take any questions now.
Okay, so for folks, there's an online Q&A window if you'd like to pose questions there. In the interim, while we wait for people to pose questions, Tracy, I would just make a comment that in Alberta, recently we've had two different sort of natural disasters that I think are kind of you know, extreme weather or extreme events. We had the Fort McMurray wildfire, which I think set a record for the cost of a natural disaster. And we also had, about 5 years ago, we had severe flooding within Calgary, Alberta. So, you know, I was watching a presentation by a doctor from Wollongong University in Australia. And what he was working on was the installation of, he was actually working in Jakarta, who's had really horrible severe flooding within their city of Jakarta. And he was working on installing sensors, you know, on bridges. And what he was talking about was using an open source approach that you could really bring down the cost of the devices so that you could get to that scalable deployment. If you use a proprietary approach, he was saying, well, you know, I don't know, my university can't afford to basically use proprietary devices. We can kind of cobble together using Raspberry Pi or whatever, you know, kind of open source, open hardware. So I think this technology, and, you know, I would mention for the folks to consider too, like both the UK and the US governments have, despite having sort of fairly radically different parties being elected fairly recently, have continued to support their open source projects. And what I found is they're saving not just millions, but billions of dollars in the use of open source technology within the government ecosystem. So within climate change, like you said, Tracy, I think the use of open source, can we afford not to use an open source approach? I don't think so.
Yeah, no, I like that. I think it is the case. Can we afford not to? And yeah, just touching on the flooding example. Yeah, even not from me. We've got Oxford, and they've got their own flood network. And yeah, similar to the examples you're given, they're basing it all on open source, not just software, but hardware. And as a result of doing that, of course, naturally it's a lot cheaper, but they're finding that it is invoking a citizen type response. So people are getting involved and they're putting down individual sensors. So it's just having that network effect, which really does mean you can scale quickly and, just cut costs dramatically. So yeah, really, can we afford not to?
Yeah. Well, and the other thing I would comment is, the Eclipse Foundation headquarters are located in Ottawa. That's where Mike works out of, right? And within the Internet of Things working group, you have two different firms. Steve Liang's Sensor Up startup out of the University of Calgary, and then of course Sierra Wireless out of Richmond, BC.
Okay,
So there is some seeing as how we're being very patriotic this year and it's Canada 150, I thought I'd throw that in.
Yeah, no, it definitely it's very much a global affair, but Canada is very well represented. In fact, one of the conferences I'd been to not long ago, we had the Canadian Space Agency. They came along and they've got some great projects which have overlap with the scientific work and some of the location tech things, and it's quite exciting sort of seeing what they're doing and seeing how we can all work together in the future. So yeah, lots of good stuff coming from Canada.
Well,
and happy anniversary as well.
Yeah, we're such a young country. So waiting on folks, I mean, I think, in waiting on a few questions, there's still this conversation about where do you think people or governments should go next as far as, the use of open source as a way to, I would call it internet scale responses. And I would introduce, what Dr. Peter Arnfalt presented from Lund University in Sweden. What the government of Sweden has done, which is really quite interesting, is they've instituted a policy that discourages business travel and encourages virtual meetings, like what we're doing right now. And what they've found, Tracy, is that the CO2 emission reduction for ministries that implemented that philosophy, they reduced their emissions by something like 9.3%, whereas ministries that didn't implement that philosophy, they actually increased their CO2 emissions by 10.4%. So you got kind of this 19% spread in terms of CO2 emissions. So if you look at, and I guess the point I'm getting to within that, it's not just technical innovation, but like Peter said, it's really about a combination of technical and social innovations.
Yeah.
You have to get government to practice what we preach, kind of deal, and reduce our carbon emissions through the way we do things. And that's really at the core of what the speaker series is about.
Yes, and certainly, the shared practices is a great one, and I like that example. One of the other things for government, I think, is definitely around policy, and definitely seeing more policy on sort of open data and making that available and sharing that, so it's not just kind of used by specific corporates or things like that. And I think an interesting one I learned about last week is that a lot of research funding from governments is now being favored towards anyone taking an open source approach. So I know Eclipse Foundation has got involved with lots of research projects, and these get strengthened by the fact that everybody who's working on the research project has taken an open source approach. So I think, yeah, biasing funding towards anything that's doing it in an open source way is definitely a good policy to have.
So Tracy, you've got kudos on a great presentation and a question of what sorts of factors do you think help open source projects succeed, and what barriers do they face? For example, is project management different in this sector than elsewhere? And finally, can participants have competing interests within a working group?
Okay, yeah, so can you just go through those one? I'll
Sure.
take those one.
Okay, so first part, what sorts of factors do you think help open source projects succeed, and what barriers do they face?
Yeah, so all sorts of things. So success, it kind of comes down again to sort of sharing these best practices and building a community around a project. I think when we have lots of projects start off typically from one vendor, and then the key is getting other people involved and having diversity of people and diversity of companies, and making sure that the infrastructure to support that works well. And any projects which don't do this have typically failed, and we see it's quite brutal in the open source world. You see projects regularly failing, and this can be down to anything from just not being very focused on what value they're adding, to just not being open to other people contributing, or to just having sort of a bad environment and making it kind of not appealing for people to get involved in. So there's definitely an art to it, and I think in the community we're constantly having these discussions of how do we lower the barriers to people getting involved, and what worked 10 years ago doesn't necessarily work today. So improving the user interface, just using the latest technologies, things like GitHub, just to make it really, really easy for contributions. So it is all about sort of continually adapting to a very, very fast changing world.
Mm-hmm. And part two of the question was, can participants have competing interests within a single working group?
Yeah, absolutely. And this happens all the time in the working group. So I think there's a co-opetition, or yes, certainly like with the CDT and the C and C++ development tools, all the companies working on it were all hardware vendors, basically trying to sell their processors or their cores. So they are all in competition, but it is something that companies are getting much better about saying, well, even though we are competitors, we are going to collaborate, particularly on infrastructure. And I think it helps companies focus on knowing what is their specific value add, and knowing that they can keep that special, but at the same time they can work with other companies to, I think the expression we use is to make a bigger pie. So just increase that whole industry so that there's a lot to go around. So yeah, it happens all the time.
So another question is about, we've heard about this ransomware, and which highlights the whole idea of security. How secure is open source software?
Yeah, no, I say open source software is great. It's the beauty of it is that it is open and there is nothing hidden from users. So when you come to adopting open source software, there's nothing to prevent you from being able to see what's there. And also there's this benefit we talk about as well of, in many cases there's many people looking at the same software or using the same software, so you've got some level, it doesn't always work, but to a certain extent over some proprietary approaches you've got more people kind of collaborating on the quality of it. So I definitely say the open source software benefits in the best cases from just being much higher quality. but like all software, it is vulnerable.
So another question is, what exactly is GitHub?
Oh, okay. So it's, without wanting to go into promoting a specific vendor more than I have already.
Yeah.
It is a tool that allows sharing of source code, and it's a tool that has made it particularly easy for people to see and contribute to open source software.
Okay.
So yeah, it's something like whenever we have interns and they're getting started on open source projects, day one is go to GitHub, create an account, and then create a pull request on an open source piece of software, just so they can see the process of saying, oh, I'm going to take this, fix something simple like a spelling mistake, and commit that, and then they get that instant gratification of they've changed something that's out in the world, and the developer could be in another country, another place, and it's extremely gratifying for them to do.
Well, and a good example of that is Todd Wilson of the BC government has agreed to speak, Tracy, and he talked about just that. They are using open source for environmental monitoring, and they have a shared database of environmental monitoring data. And he said that they only have money to kind of contract and clean things up kind of like maybe once a year. And he said they kind of posted stuff through GitHub, and what they found was there was some crazy programmer who just said, well, look, I fixed it, so like check it out, it's done. And Todd said, well, excellent. So they've actually implemented, what did he call it? It's almost like a bidding system where programmers they literally it's crazy good. They post problems to a shared kind of GitHub presence, and people can bid on solving those problems. And Todd was saying they've gone from having like a 4-month response time to something like 4 days to get things solved. So I mean, that's such a different problem-solving time frame that like, honestly, this is kind of like a new paradigm of problem solving, because you can have the shared intellectual abilities from literally throughout the world.
Yeah, no, it's great. It's really magical. I love that story. Yeah, 4 months to 4 days. That's amazing.
Yeah. So Tracy, this has been a wonderful presentation, and I'm so happy that you agreed to participate and present. It's wonderful, and thanks so much for doing this. It's been great.
Yeah, no, thanks for having me. It's been wonderful from my side too.
And of course, we'll be posting this to our YouTube channel, and any of the folks that have been watching, you'll be able to find that just by searching within YouTube for MCCAC. And usually, the presentations are posted, within 2 to 3 days. And that's exactly what we'll do with this one. It's a wonderful presentation.
Good. Thank you very much. My pleasure.
Excellent. Well, thanks so much for doing this.
Okay.
Okay.
Bye, everybody.
Bye now.